Hello everyone, welcome back to the channel. So today we are diving into one of the most exciting topic in coordinate geometry. It helps us understand how shape moves, flip, turn or grow on a grid. You see the example here. Here is a quick look at the four main types of transformation: translation, rotation, enlargement and reflection. In this video, we are going to dive deeper into one of this transformation, reflection, and understand how it works on coordinate grid. Before we go ahead, let's see the definition of transformation. A change in position or size of an object is called its transformation, and the position or size of the object after the transformation is called image. That means, in this case, this is object, and after the transformation the figure is called image. These all are image. And now there are mainly two types of transformation: isometric and non-isometric. In isometric transformation, you'll see that object and image are congruent to each other. They're exactly same. They're congruent to each other. And you'll see this type of transformation in reflection, rotation, and translation. Whereas non-isometric transformation means in which the object and the image are similar. That's you can relate with the enlargement. They are not congruent, but the images are similar to each other. Today we are focusing on reflection only. So before we go ahead, we'll see some of the examples, basically real life examples that happens around us every day. You can see the figure. In the first figure, you see the swan on the lake, and then the tree reflected on still water, and even your face in the mirror. They all are real life reflection happening around us every day. Even on an ambulance, have you ever noticed the word ambulance is written in reverse? You know why? This is because it meant to be seen the right way around in a rear view mirror. I'll show you here. When we flip it, can you see? That's the reflection. This is one of the example of reflection. See, when I flip it, you'll get the real image. And math has a way to reflect things too. So grab your notebooks because we are about to reflect some shapes and ideas. So as I said, we are focusing on reflection here. Let's see what reflection is. So reflection, which is also a flip. So reflection means what does reflection does? It flips an object about a line, and that line is called line of reflection. We'll see with an example here. I'm going to paste one image and we are going to reflect it around y-axis. The y-axis will act as mirror here. Okay. Now we have to reflect the object here, A, B, C, D, E. Let's say this is an object. We have to reflect it considering y-axis as mirror. Now, remember the distance between the object and a mirror is same as the distance between the image and the mirror. That means the object and the image are equidistant from each other. So if B is here, which has 2 units gap from the mirror, that means the image of B, which is called B dash here, you'll see the coordinate, it will be 2, 5. It is basically 2 units from the mirror. Similarly, D, you see it is 4 units from the mirror, so that its image also will be 4 units away. So D dash, which is 4, 1. Similarly, the other one, you'll see that this one is 2, 4, and the other one, A will be here, which is 7, 5, and then E will be 7, 1. Now let's connect them. This is the image. This is the image. I'll write here image, and this is object. So we reflected object A, B, C, D, E about y-axis. You notice here that object and the image are equidistant from the mirror. Also, you'll see that when I flip this image, it will exactly fit on object. Now, I'm gonna flip it. This is the flipped image. Now, if I put here, can you see it exactly fits here? That is why the object and the image are congruent to each other. That is why reflection is isometric transformation. What was isometric transformation? That the object and image are congruent to each other. The line flipped the image, and the y-axis is the line of reflection. Okay, now you see the rule. You see that a coordinate changes to, which was minus 7 comma 5, changes to a prime, which is 7 comma 5. Similarly, b dash, b, which is minus 2 comma 5, it changes to 2 5. You see the pattern it follows. What is the pattern? I'll not write all. That means if I say that pxy, what will be the image for that? It will be minus xy. So that's the formula. You learn it. You can do directly. So when you are reflecting an object about y-axis, this is the formula which you have to remember. Now we'll see for the x-axis. Now we're gonna reflect an object on about x-axis. This is the thing. The rule is same. Now let's reflect this figure first. Let's say this is figure A and this one is B. Let's reflect it. So it is 2 units distant from x-axis, then the image is also 2 units far. Same here. This one is 3, then 3, and then I guess 4, then 4, 4. Let's join them. You see, it's the flipped image. This is B dash. If you have to see the coordinates, you see the coordinate. Let's say this is P, Q, R, S, T. This will be P dash, T dash, R dash, S dash, and Q dash. See the coordinates. P is, I guess it's 12, 2. It changes to what? 12 minus 2. Similarly, Q, it's what? 12, 4. And it changes to what? 12 minus 4. Similarly, R, it is 18, 4. And the image which you got, it is 18, negative 4. Did you see the pattern? So that means the rule for y-axis is when you're reflecting an object around y-axis, when you are reflecting a point about x-axis, what's the rule then? The rule is the x coordinates remain same, the y will be negative of that. That's the formula which you have to remember. So you can directly flip here 3, 3, this and this. You'll get the image, which is the flipped one. Yeah, this is A prime. So that's about the reflection in x-axis and y-axis. Now we'll try a few questions where we don't have the images but the direct question. So let's see it. You remember the rule or not? So first one, we have to reflect in the in the x-axis. So you have to find the coordinates of the image points. So you have to reflect in x-axis. So what's the rule? What will be the coordinates of the image? It will be x remains same in x-axis. You can see the example here where the y becomes negative. What about this one? This one will be 3, 0 because negative 0, which is 0. This one, negative 2, negative 4. This one, minus 1. And what is negative of negative 3? That will be 3. And this one, 2, sorry, negative 2 and negative of negative 2 is 2. That's about the reflection in x-axis. Now let's see y-axis. So remember y-axis? In y-axis, when we reflect about y-axis, when we reflect a point about y-axis, the coordinates, you'll see y remains same, whereas the x coordinate is negative. So its image will be negative 4, 5. Similarly, you can do other. This one is negative of negative 3 is 3 minus 1. Negative of negative 4 is 4 and negative 8. Similarly, let's do this one. 1, 3 and negative 7 and 2. With this, I hope the reflection in x-axis and y-axis it's clear. Now, we'll go to next, where we'll see the reflection about horizontal lines. For example, let's see the question here. We have to reflect shape A in the line. So you see the line of reflection, this time it's x is equals to 2. So we need to reflect the object. Which object? The shape A in the line x is equals to 2 and label the image as A1. Let's make x is equals to 2. So this line is x equals to 2. Now this will act as mirror. Now let's reflect it with respect to the line x is equals to 2. The rule is same. The gap between object and the image from the mirror is equidistant. So 1 unit gap and then 2 units, right? 2 unit gap and here, then 3, 3 and this. You just analyze here, estimate it. This is A1. That's the image which you will get after reflecting it in the line x equals to 2. Let's reflect in now x is equals to minus 1. So let's draw the line x is equals to minus 1. Now we have to reflect B. 4 units gap, it will be 1, 2, 3, 4 here, then here, then here, and you can analyze, you can estimate here. This is the thing, and you get B1. For x is equals to 1, I guess you can do this one. Now let's try D. Shape B1 is the reflection of shape A. In which mirror line? Let's find the mirror line. So if you draw the mirror line, this is the mirror line. I think we are reflecting. This will act as mirror here. So what is this line? Can you name it? Can you tell me the equation of this line? Is it y equals to 7? Reflection of A about y equals to 7, it's B1. Let's see the reflection of the objects above the line y equals to x. Let's find the image for the square one. Remember, I told you distance between the object and the image it's same. So if for this one, I guess the image will be here. Similarly, let's draw the line for this one, a perpendicular line, okay? So the perpendicular line, I guess this much gap, see? The distance should be same. So the image for this black point will be here. Now you can guess it. Otherwise, we'll go with the proper form. Here, 2 units gap. And the image for this blue dot will be here. And we can guess for the other one. Draw it. That's the image. And that's the image for a square about y equals to x. So this is the reflection of the objects about a line y equals to x. Let's name the sides. Let's say this one is A, B, C and D. This one is A dash, B dash. My bad. This one should be D dash, C dash and B dash. Now what's the coordinate of A? Can you check it? It's 3, 7, right? Now what's the image when you're reflecting about y equals to x? So what's the image here? Can you see it? It is 7, 3. Did you notice it's get flipped? Now what's B? B is 1, 7. And when you reflect it, it will be 7, 1. Similarly, C is what? What's C? 1, 5. And when you see the image, it will be 5, 1. So similarly for D, 3, 5 and the image will be 5, 3. So that means if I have to write the rule of the reflection for a point y equals to x, it will be yx. That's the rule. That's the rule for the reflection about y equals to x. Similarly, you can try for other three figures. I hope it's clear whatever we did. We did reflection in x-axis, y-axis, on the horizontal line, vertical line, and the reflection about y equals to x. That's it for today. I hope you like it. Don't forget to like, share, and subscribe. Thank you.